So for question 17 from the practice exam, right, they tell us they've got 10 grams of this refrigerant, 10.1 grams of this R32, and they want to know how many atoms of fluorine are in that sample. So to map this out, right, we're going to start with grams because that's what we have. We know we can go from grams to moles using the molar mass, right? That's the only thing that relates grams to moles. And then once we have moles, right, we can use Avogadro's number to find molecules. And then the step that we haven't practiced a whole lot or haven't seen too much yet is the last step, where we can go from molecules to atoms. And to do that, we're going to use the molecular formula. We're going to use the fact that there are 2 fluorines in each molecule to find the total number of fluorine atoms we have in the sample. So we're looking at 3 steps here after we figure out the molar mass of this. So for the molar mass, right, carbon is 12.01. I've got 2 hydrogens at 1.01 each, so that's 2.02. And then I've got 2 fluorines at 19 AMU each. Right, so 38 plus 2 is 40. All right, so 52.03 grams per mole is the molar mass of CH2F2. Right, we need that for step 1 because step 1 is going grams to moles. So 10.1 grams. We went to the periodic table to figure out for every 1 mole of that. Right, we got these numbers from the periodic table, the molar mass of carbon, hydrogen, and fluorine, to see that that was 52.03 grams per 1 mole. So 10.1 divided by 52.03. And we get like 0.194 moles. All right, step 2, moles to molecules using Avogadro's number. So 0.194 moles, right? We know 1 mole of anything, got Avogadro's number, 6.02 times 10 to the 23, in this case, molecules. Multiply by Avogadro's number. All right, we get 1.168 times 10 to the 23 molecules. Right, we'll figure out significant figures later. Because step 3 is the step we haven't practiced a whole lot, right? Step 3 is where we would go to the formula to see that I have 2 fluorines for each 1 molecule. So literally all we're going to do in the last step is multiply by 2, because I've got 1.16 times 10 to the 23 molecules. And I can look at the formula, and by the formula I can say for every 1 molecule, right, that subscript 2 tells me we have 2 fluorine atoms. So we multiply by 2 to get our final answer. Right, and so how many significant figures should we have here? Yeah, 3 significant figures, because the 10.1 grams, so 3 significant figures, right? 2.34 times 10 to the 23 fluorine atoms for that question. Right, so it was just that last step was something we really hadn't practiced before too much, of how do I go from molecules to atoms. For that conversion factor, we're going to go to the molecular formula, because the molecular formula tells me how many of that atom I have per molecule for question 17. Yeah.
Question 17, you wrote that there's, what is it?